Hello, this is our demo for implementing a security application on an open source software-defined network. Here is the topology we will be using for our demo today. We have implemented our core, distribution, and access layers using our Dell VEPs that are running Red Hat on them. We have our Open Daylight controller running on this VEP router, which will be installing the flows onto this OVS1 switch. We have 6 simulated hosts under our access layer as shown in the topology. For today's demo, we will be demonstrating the functionality of our security application while we run a ping from host 1 to host 6.
Okay, so we're going to have a continuous ping running from H1 to H6 here, and around ICMP sequence 15 or 14, we will see our application come into effect. It'll be ran to block H1 to H6 traffic. And there we go. You can see the packets lost at the end there, and just once again to prove that none are getting through, 3 transmitted and 100% loss. Now we're going to ping all of them, see if we have full reachability still, and we still do. H1 can ping H2, H3, H4, and H5, except H6. Now H6 can't get back to H1 as well, but it will succeed with all the rest of the hosts. So this screenshot here shows the application actually being ran. It's a Python program. It accepts some arguments. Right now it's just blocking by IP address, so it takes 2 IP addresses, source and destination. You can see it says success there in status code 200. It will return the status code of the REST call and give debug information based on what the response is. If it's a 400 or 500, it'll give you responses based on what there most likely is. So here's the flow table of switch 1, and you can see the flow that's being added from our application here. You can see because the cookie 0x37, that's how we identify our flows. You can also see that it's matching by network source and network destination actions drop. You can also see there that a number of packets is 0. That's because it's caught 0 so far, but after we ran the ping tests, you could see in the mininet video, you'll see the number of packets increase. And this picture here, you can see this was after the ping test was done, and the number of packets is 7. We could use this in an IDS if we have lots of match statements to stop potential attacks, and their number of packets starts skyrocketing. Then we can tell that obviously there's something happening. And also we can detect DDoSes potentially, because if a single flow that's a normal flow, not one meant to be a security one, if its number of packets starts to skyrocket, that might mean that there's a DOS attack or some other networking issues. And in this screenshot here, this is what the XML file looks at, is dynamically created with Golang. This is essentially what has to be created dynamically and sent to the controller, and the controller will take this XML data and convert it into OpenFlow data and send it to the Open vSwitch instances, and they will install this on the in its flow table. You can see it's got a match statement where it matches the Ethernet and Ether type and then matches the IP destination. Now, obviously, you can add stuff like TCP ports, like I mentioned earlier, and a bunch of other things, so it can match plenty of other things. And it's the same with the below match there's instructions, which is essentially the action, what action is to be taken. Yeah, you can see it there in action, then drop action. So right now it's just dropping, but you can forward it either to the controller to host X, Y, or Z, port X, Y, or Z. You can even mirror packets, so you can send it out multiple ports at once, kind of like span. And there's lots of different things you can do with the action statement as well. And this is all dynamically created in Golang. And once this is created in the application is ran, the arguments are passed to the Golang function. It creates a dynamic XML like the one you can see right here. And then the Python program sends this XML file to the controller. The controller then takes this XML data and turns it into OpenFlow data and sends it to the Open vSwitch servers. And they install the flow in their flow table based on this data.
And that's our demo for our security application on an open sourced SDN. Thanks for watching.